Hi guys, and welcome to our module on the blood supply and the lymphatics of the abdomen. So the vascular structures of the abdomen tends to be derived from three major structures. These structures include the abdominal aorta that supplies blood to structures within the abdomen, the inferior vena cava, which drains deoxygenated blood from each of the structures, and then finally a bunch of lymphatic nodes and vessels that forms what we call the abdominal lymphatic system, which drains lymphatic fluid from the abdomen and drain it back into the venous system. So starting off with the abdominal aorta. The abdominal aorta is the largest artery in the entire abdomen. It's the main arterial supply of blood, of oxygenated blood to the anatomical structures of the abdomen. It measures about 13 centimeters in length. We'll talk about its extent in the next slide, in terms of how it starts, how it runs, and then eventually how it terminates. So in terms of the origin of the abdominal aorta, it tends to originate as a continuation of the thoracic aorta. The junction at which we have the thoracic aorta becoming the abdominal aorta is at the aortic hiatus. The aortic hiatus is an opening found on the diaphragm. It's one of the three major openings of the diaphragm, and it usually coincides with the 12th thoracic vertebral level, so at T12. So at T12, we have the aortic hiatus being present on the diaphragm, and then that point is where we have the thoracic aorta transiting into the abdominal aorta. Once the abdominal aorta is formed, it descends through the entire abdomen. It's found largely lying on the posterior abdominal wall, and then it runs on the left side of the abdomen towards the pelvis. The abdominal aorta tends to terminate by dividing into two parts. So at around the junction between the fourth and fifth lumbar vertebrae, so L4, L5, we have the abdominal aorta bifurcating. So it bifurcates into two major arteries. This includes the right and the left common iliac artery. You could see that bifurcation in this image. You have the right common iliac and the left common iliac arteries being the continuation of the abdominal aorta. Let's jump to the branches of the abdominal aorta. We have a number of arteries that tend to come out of the abdominal aorta to supply some of the structures we find in the abdomen. Now we tend to talk about the branches of the abdominal aorta in terms of three major forms of classification. So we can classify the arteries as either being paired or unpaired. So meaning they are the paired ones would be arteries that have right and left sides, or right and left counterparts. The unpaired arteries are just arteries that just have a single unit, just come out of the aorta in a single form. We could also classify arteries or branches of the abdominal aorta into either anterior branches, lateral branches, or posterior branches. This is talking about the part of the abdominal aorta in which they come out from. So anterior branches will be arteries coming out, or branches coming out from the anterior wall of the abdominal aorta. Lateral branches will be coming out from the lateral part of the abdominal aorta, and then finally posterior branches comes out from the posterior part of the abdominal aorta. And then finally, we could also classify branches of the abdominal aorta into branches or arteries that are supplying either visceral structures. So visceral structures include organs like stomach, the intestine, the liver, and the likes. Or we could classify those branches as branches that supply the body wall. So body wall like the diaphragm, the posterior abdominal wall, the anterior abdominal wall. So in this case, we define those arteries as being parietal arteries. So we have either visceral arteries or parietal arteries. Jumping into the actual branches of the abdominal aorta. So let's list them, and then we'll talk about each of them one by one. So we have the celiac artery, then the superior mesenteric artery, the inferior mesenteric artery, the suprarenal artery, the renal artery, the gonadal artery, the inferior phrenic artery, subcostal artery, and then finally the lumbar artery. Some of these arteries, just by their name, you could easily deduce in terms of what they are going to be supplying or where they are going to be found. One artery I didn't add to this tend to be the median sacral artery. We'll talk about that towards the end of this particular aspect on the abdominal aorta. Now let's jump to the celiac artery. Celiac artery, in terms of its classification, is classified as an anterior artery. So it's an artery that comes out from the anterior wall of the abdominal aorta. You can see the origin point of the celiac artery here. You can see it's coming out from it's coming out anteriorly from the abdominal aorta. It's an unpaired artery, meaning it just has a single unit. It doesn't have a right or left counter, but it's not bilateral, it's a unilateral. And also, it's a visceral artery. It's an artery that supplies visceral structures. I'll talk about some of the structures it tends to supply. It arises from the 12th thoracic vertebrae, so T12, and the particular visceral structures that the celiac artery will be supplying is known as the foregut structures. So the foregut structures include structures um, like the stomach, the abdominal esophagus, the spleen, the liver, the gallbladder, and the part of the duodenum, usually the very first part or portion of the duodenum above the and then the part of the duodenum that is above the major papillae. So these are foregut structures found within the abdomen that are all supplied by the celiac artery. To talk a little bit about in much detail about the component of the celiac artery, I just had this diagram to show you so we can just dissect um, yeah, in terms of the branches of the celiac artery. It's important to know this because this is one area that they tend to talk about the most. This is one artery that we tend to talk about the most amongst all the other branches. So note that the celiac artery, once it emerges from the abdominal aorta, branches into three major sub branches of arteries. So this includes the left gastric artery. So the left gastric artery is the first branch, then the splenic artery, that's the second branch, then the common hepatic artery. So the celiac artery gives rise to three branches: the left gastric artery, splenic artery, and the common hepatic artery rather. The left gastric artery would run down towards the lesser curvature of the stomach to supply that lesser curvature of the stomach. The splenic artery runs in the tortuous fashion towards the spleen to supply the spleen, and as it's going towards the spleen, it gives us some minor arteries that will supply the stomach. So it gives off the left gastro-omental artery, the posterior gastric artery, the short gastric artery. Those arteries are coming from the splenic artery. They supply the stomach. For the common hepatic artery, so this artery will form a number of branches. Once the common hepatic artery comes out, it gives off about 3 to 4 different branches. It gives off the right gastric artery. So you can see the right gastric artery coming from the common hepatic artery. This right gastric artery will now go further to join with the left gastric artery, and both of them will supply the lesser curvature of the stomach. Besides the right gastric artery, another branch of the common hepatic artery is the gastroduodenal artery. You can see this artery here. The gastroduodenal artery emerges from the common hepatic artery. The gastroduodenal artery tends to run down and then splits into sub branches. So it splits into what they call the right um, the right gastro-omental artery. So you can see the right gastro-omental artery being the terminal branch of the gastroduodenal artery. That right gastro-omental artery will run on the greater curvature of the stomach and also mix with the left gastro-omental artery. That has the artery that's coming from the splenic artery, and both of them would supply the greater curvature of the stomach. You can see how some of the supply of the stomach is coming from branches of the celiac trunk. So celiac trunk gives branches. Some of those branches gives other branches, and some of those branches are involved in supplying different aspects of the stomach. The other terminal branch of the gastroduodenal artery tends to be the pancreaticoduodenal artery. So the pancreaticoduodenal artery would supply the pancreas and the duodenum, and remember that it's supplying the part of the duodenum that is gotten from the foregut. Then the last branch of our common hepatic artery is what we call the proper hepatic artery. You can see this artery here, and that proper hepatic artery is going to run all the way towards the liver and the gallbladder to give supplies to both of the structures. Let's move on to the superior mesenteric artery. The superior mesenteric artery, just like the celiac artery, is an anterior artery that is unpaired and is supplying visceral structures. It arises just directly below the celiac artery at the first lumbar vertebral level at L1, and it supplies the meagut structure. So meagut structures would be the duodenum or part of the duodenum below the major papillae, the the jejunum and ileum, as well as the cecum appendix, and then the proximal to third of the transverse colon and ascending colon. So those are structures that we refer to as derivatives of the midgut. They are all supplied by the superior mesenteric artery. Superior mesenteric artery has its own set of branches. It has the jejunal and iliac artery that supplies the jejunum and the ileum. It has the it also has a branch that goes to supply the duodenum known as the pancreatical duodenal artery. So the same way we have pancreatical duodenal artery gotten from branches of the celiac trunk, we also have pancreatical duodenal arteries gotten from branches of the superior mesenteric artery. So that way it gives a full supply to the duodenum. Then um, we have our ileocholic artery that will supply the cecum, the appendix, and then part of the ileum. We have the right cholic artery and middle cholic artery supplying the ascending colon and the proximal third of the transverse colon. And then the inferior mesenteric artery is the third on our list. It's just like the superior mesenteric artery and celiac trunk in terms of classification. It's an anterior artery that is unpaired, that is supplying visceral structures. It arises from L3, just a level below or two levels below the point of origin of the superior mesenteric artery, and it supplies the hindgut structure. So what are the hindgut structures? This includes the distal one third of the transverse colon, the descending colon, the sigmoid colon, and then moving down all the way to the rectum. Some of the branches of the inferior mesenteric artery supplying each of these hindgut structures includes um, branches like the left cholic artery, the middle artery, the middle cholic artery, the marginal artery, and then the sigmoid artery. These are arteries coming from the inferior mesenteric artery. So our fourth artery on the list of branches of the abdominal artery is the suprarenal artery. This is an artery that is lateral in classification. It is paired, meaning it has right and left parts. It supplies visceral structures, and it arises from L1 in terms of the vertebral level, just at the same level with the superior mesenteric artery. In terms of the particular visceral it supplies the adrenal gland, also known as the suprarenal gland. The fifth artery, as a branch of the abdominal aorta, is the renal artery. It's a large artery that is classified as being lateral, being paired, and also being visceral in terms of its supply. It arises from the junction between L1 to L2, and it is supplying the visceral structures that includes the kidney and part of the abdominal ureter. Then we move on to the sixth artery, which is the gonadal artery. The gonadal artery is also a lateral artery in classification. It's paired, meaning there are right to left parts of it. It supplies visceral structures, as we would see. It arises from L2, just directly below the renal artery, and it is involved in supplying gonadal structures, hence the name. It supplies ovaries in the female and the testes in males. Now let's jump into some of the arteries that would supply parietal structures. So the first would be the inferior phrenic artery. This is an artery that is similar in terms of classification to some of the arteries we mentioned before, like the renal and the gonadal artery. So in terms of similarities, these arteries tend to be classified as lateral and paired, meaning that they originate from the lateral aspects of the abdominal aorta, and they tend to contain right and left parts. In terms of the differences between the inferior phrenic artery and then the arteries that we mentioned previously, the inferior phrenic artery is a parietal artery, meaning it's going to be supplying body structure walls, not visceral organs. It arises from T12, similar to where the celiac trunk is arising from, and the particular body wall that the inferior phrenic artery supplies is the diaphragm. So it supplies that abdominal portion, or the diaphragm, the inferior surface of the diaphragm. Then we have the subcostal artery. Subcostal artery is classified as a lateral artery that is paired, that is also supplying parietal structures, and arises from L2. It supplies the posterior abdominal wall, and as a result, it is classified as parietal artery from there. Then we have the lumbar arteries. The lumbar arteries are lateral arteries that are paired and also supplying parietal structures. There are actually four lumbar arteries present within, originating from the originating from the abdominal aorta, not just one of them. So if you notice, you see the lumbar artery, you can see one of the lumbar arteries here, you can see other lumbar artery here, and then high up, so other lumbar artery here. So we have about 4 lumbar arteries, and based on the fact that there are four, they tend to arise from the 4 different portions or 4 different vertebral levels. So we have them arising from L1, L2, L3, all the way down to L4. The part of the parietal structure or body wall that they supply is the posterior abdominal wall, just like subcostal arteries. The final artery as a branch of the abdominal aorta is the median sacral artery. This artery is the only posteriorly placed artery, so it originates from the posterior wall of the abdominal aorta. It is unpaired, just like our celiac, trunk, superior mesenteric, and inferior mesenteric. And unlike them, it tends to supply the parietal structures, which is the body wall. So it supplies the posterior abdominal wall, and it arises very lower down at L4, at the point just above the point of termination of the entire abdominal aorta. Let's move on to talk about the relations of the abdominal aorta. So what are the structures that are related to the abdominal aorta anteriorly, posteriorly, laterally, and otherwise? So anteriorly, we have a couple of structures, about 6 structures found in front of the abdominal aorta. This includes the celiac plexus and ganglion, the body of the pancreas, the splenic vein, the left renal vein, the third part of the duodenum, and the cores of the small intestine. These are structures that are found. So the abdominal aorta is found largely towards the posterior abdominal wall, meaning there will be a lot of structures found in front of it, or a number of structures found in front of it. Hence the reason why we have this list of structures found anteriorly to the abdominal aorta. Posteriorly, we have the bodies of the 12th thoracic vertebrae down to the 4th lumbar vertebrae as posterior boundaries, as well as the left lumbar veins. To the left of the abdominal aorta is the left crus of the diaphragm superiorly and the left celiac ganglia. To the right of the abdominal aorta, we have a number of structures. This includes the inferior vena cava. You can see the inferior vena cava just on the right side of the abdominal aorta. The azygos vein, the cisterna chyli, which is part of the lymphatic system that we'll talk about very soon. Thoracic duct, which is also part of the lymphatic system we'll talk about very soon. And then superiorly, we have the right crus of the diaphragm and the right celiac ganglia. The next major structure to talk about in this particular model will be the inferior vena cava. This is the largest vein or the largest venous structure found within the abdomen. It's involved in the drainage of venous blood within the abdomen. It's the main destination of venous blood drainage in the abdomen. It is a valveless vein and measures about 20 centimeters in length. We'll talk about everything we need to know about the inferior vena cava in terms of its origin, its cause, and then its termination. The inferior vena cava is a vein that arises in the opposite direction to the origin of the aorta. The abdominal aorta arises higher up from the level of the diaphragm. The inferior vena cava tends to arise lower down at the level of the pelvis. It arises from the union of the right and left common iliac vein. So the right and left common iliac veins will unite together to form the inferior vena cava, and these tend to occur at the level of L5 or the 5th lumbar vertebrae. Once the inferior vena cava is formed, it begins to ascend. So it ascends through the posterior abdominal wall, running on the right side of the body. So it runs on the right side of the body, in contrast to the abdominal aorta that runs on the left side of the body. Then it approaches the diaphragm, and at the caval opening of the diaphragm, it pierces through that opening to enter into the thorax, where it terminates. I'll talk about the termination very soon. So please do note that the caval opening of the diaphragm is or corresponds to the 8th thoracic vertebral level, T8. Just as the aortic hiatus of the abdominal aorta corresponded to the 12th thoracic vertebrae, or T12. So moving on to the termination of the inferior vena cava, it ascends into the thorax, and once it gets to the thorax, it runs a little bit upwards towards the heart, and then at the right atrium, it terminates by emptying into the right atrium. That is why we say that the oxygenated blood gets into the right atrium. That deoxygenated blood coming from the entire abdomen and pelvis is taken by the inferior vena cava into the right atrium. So just as we had branches to the abdominal aorta, we also have some branches to the inferior vena cava. Actually, we call them tributaries. So tributaries of the inferior vena cava would be veins that tend to drain into the inferior vena cava. So all the venous blood in which these veins tend to carry would enter into the inferior vena cava. This includes the inferior phrenic vein, then the lumbar vein, and then we have the renal veins, the suprarenal veins, the gonadal veins, and then the hepatic veins. We'll talk about each of these veins in terms of what they drain, and then for some of them, we'll talk about how they tend to terminate. Starting with the inferior phrenic vein. Inferior phrenic vein drains venous blood from the diaphragm and the aim, so it's a counterpart to the inferior phrenic artery. The lumbar veins drain the posterior abdominal wall, just like the lumbar arteries supply oxygenated blood to the posterior abdominal wall. Then moving on to the renal vein. This is a vein that is bilateral, so it will be draining the right and the left kidneys. Then we have the suprarenal veins, and this is where it gets a little bit interesting. So suprarenal veins ideally will drain the suprarenal glands or the adrenal glands. But in terms of these veins and how they tend to terminate, so please do note on the right side, the suprarenal vein on the right side tend to empty into the IVC, whereas the suprarenal vein on the left side tend to actually empty into the onto the left renal vein. So if you notice, the right suprarenal vein enters directly into the IVC. The left suprarenal vein enters into the left renal vein. So it enters into the superior part of the left renal vein as shown here. And please, that is very key to remember. A very similar form of termination is also seen in the gonadal vein. So the gonadal veins will be veins that drain the gonads in the male or females. That will be the testes and the ovaries respectively. So do note that in terms of drainage of the gonadal veins on the right side empties directly into the IBC. You can see that in this picture. Whereas the gonadal vein on the left side, just like the suprarenal vein on the left side, also terminates into the right into the left renal vein. So please do note the left renal vein receives two veins before it terminates. The left renal vein, it receives the left suprarenal vein and the left gonadal vein. And all three together, the venous blood of all three together would eventually empty into the IVC. So please do note that difference. The last vein not shown well in this image would be the hepatic vein. The hepatic vein is a vein that is actually going to be draining the liver, and the is a vein. Okay, it is actually shown in this image. Apologies. So this would be the hepatic veins here. You can see the hepatic veins draining the liver, and about three of them entering directly into the superior part of the IVC. Now, please do note that the veins that tend to correspond to those unpaired visceral branches of the aorta, like our celiac trunk, the superior mesenteric artery and inferior mesenteric artery. Remember that these are arteries that drain visceral structures like the stomach, the foregut, the midgut, the hindgut, practically. If you're wondering where are the venous counterparts to these veins, the venous counterparts to this vein actually is the hepatic portal vein. So the hepatic portal vein collects venous blood from the superior mesenteric vein, from the inferior mesenteric vein, from the splenic vein, and then eventually drains that blood not into the IVC but to the liver. So do note that for all those arteries that we mentioned in terms of the branches of the aorta, the only ones that don't have their venous counterparts draining into the IVC will be the counterparts to the celiac trunk, the venous counterpart to the superior mesenteric artery, and the venous counterpart to the inferior mesenteric artery. So they are venous counterparts. So this venous counterpart of the celiac trunk actually is the splenic vein. The venous counterpart of the superior mesenteric artery is the superior mesenteric vein, and then the venous counterpart of the inferior mesenteric artery is the inferior mesenteric vein. All these venous counterparts actually drain into the hepatic portal vein and not into the IVC. And from the hepatic portal vein, that vein enters into the liver. So eventually, the liver will take up all the blood and eventually would drain those blood that's collected through the hepatic vein into the IVC finally. Now, this end this segment, we're talking about lymphatics of the abdomen. Lymphatic drainage of the entire abdomen comprises of a combination of lymphatic vessels and lymph nodes. They tend to lie usually along the aorta, the IVC, and then some iliac vessels. We'll talk about each of those different structures, starting with the lymph nodes and then moving to the lymphatic vessels. So lymph nodes from the abdomen receive and filter lymph fluid. that comes from a number of different structures, so coming from the visceral structures of the abdomen as well as the body wall of the abdomen. And we have a total of about um, three, actually two groups, but then just group them into a total of four different lymph nodes. So we have the lumbar lymph nodes, and the celiac lymph nodes, superior mesentéric lymph nodes, and the inferior mesentéric lymph nodes. So please do note, the lumbar lymph nodes are also known as the para-aortic lymph nodes, whereas the celiac, superior mesenteric lymph nodes, and inferior mesenteric lymph nodes as the pre-aortic lymph nodes. So please do know that distinction. Para-aortic lymph nodes include things like the lumbar lymph nodes, whereas the pre-aortic lymph nodes includes the combination of the celiac nodes, superior mesenteric nodes, and the inferior mesenteric nodes. So each of the nodes that we have that we talked about in the previous section would receive lymph and eventually will pass out that lymph to what we call lymphatic vessels. So we have lymphatic vessels that arises from each of the lymph nodes, and they will be involved in draining lymph across the entire abdomen. And all the lymph vessels end up into two main trunks. So lymph vessels coming from the para-aortic lymph nodes, which are the lumbar lymph nodes, and then lymph vessels coming from the pre-aortic lymph nodes, which would be the celiac nodes, the superior and inferior mesenteric nodes. All of this will drain into either of two main trunks. The first will be the intestinal lymphatic trunk. So the intestinal lymphatic trunk is known for draining the pre-aortic lymph nodes. So lymph nodes that tend to come from celiac trunk, the um, celiac nodes rather, superior mesenteric nodes, and inferior mesenteric nodes. So just quickly bring this in perspective. Nodes that are celiac nodes usually will drain lymph coming from the stomach, the liver, the spleen, pancreas. Lymph from the superior mesenteric lymph nodes will be coming from the small intestine, the cecum appendix, and then ascending colon and transverse colon as well. And then for the inferior mesenteric nodes, this contains lymph coming from the descending colon and then the sigmoid colon. Whereas lymph coming from the lumbar nodes rather, the lumbar nodes will be coming from the posterior abdominal wall, the kidneys, the ureter, the gonads, the ureters, the uterus rather, as in the female uterine tubes or fallopian tube, and then the pelvis. And then the all of this lymph will be drained by vessels that would eventually either end as intestinal lymphatic trunk or the lumbar lymphatic trunk. And like I said, intestinal lymphatic trunk drains lymph coming from the pre-aortic nodes. The lumbar lymphatic trunk drains lymph coming from para-aortic nodes. So just to reiterate what I mentioned, like I said, in the intestinal lymphatic trunk arises from the pre-aortic lymph nodes and then drains lymph coming from each of these structures, whereas the lumbar lymphatic trunk arises from the lumbar lymph nodes and will drain lymph coming from these various structures. So once you have the intestinal lymphatic trunk and the lumbar lymphatic trunk formed, these two will combine together with one more trunk known as the thoracic lymphatic trunk coming all the way from the thorax. And so the three of them would unite and give rise to a new structure. And that structure is known as the cisterna chyli. So cisterna chyli is the union between three major lymphatic trunks. The intestinal lymphatic trunk that drains the pre-aortic lymph nodes, the lumbar lymphatic trunk that drains the lumbar lymph nodes, and the thoracic lymphatic trunk that drains structures coming from the thorax. Once the cisterna chyli has been formed, it tends to ascend through the aortic hiatus and then enter into the posterior mediastinum. Please do note, cisterna chyli once it's formed and it begins to ascend, we stop calling it cisterna chyli. We start to call it thoracic duct. So within the abdomen, we still call it cisterna chyli, but once it passes through the aortic hiatus and enters into the posterior mediastinum, we begin to call it the thoracic duct. So within the thorax, the thoracic duct ascends all the way up to the neck, and at the neck it empties into the venous system at the left venous angle. And this is an image showing us the different lymphatic system that we talked about. You can see each of the different lymphatics, the intestinal lymphatics, the lumbar lymphatics, the liver lymphatic is still part of the intestinal lymphatics or part of the pre-aortic lymph node. You can see how each of the lymphatic vessels accumulate to give rise to the cistern chyle. Cistern chyle will eventually become thoracic duct and then ascend through the thorax to terminate at the venous angle higher up in the neck. And that concludes our module on blood supply and lymphatic system of the abdomen.